Just yesterday, Arumi released his video of the one block momentum triple neo for Minecraft versions 1.12, and I believe it works for 1.13 as well. There seems to be a lot of confusion going around on how it works, but the explanation isn't too difficult. Essentially, it's just a floating point issue to do with the X hitbox of the player's model around the powers of 2 due to how the game stores that information in bits. Circuit Store has a great video that goes into more detail about that, so I'll link that one in the description. This part I still can't explain thoroughly, but different movements around these powers of 2 cause the hitbox to get larger, smaller, or just stay at the original size. What we're looking for to complete the triple neo is a sequence of inputs that cause it to get smaller. Unfortunately, it's not as easy as just saying it, as most things end up in the hitbox getting larger or just staying that original size. This is why you see Arumi doing that strange A to D movement at the start, as that's one series of inputs that causes it to get smaller. Now, if you did try recreating that at a different power of 2, it might not have worked, which is why there was a belief that it only worked around an x coordinate of 0. However, that's just because although deterministic, there still appears to be some randomness about what makes it larger or smaller at different coordinates. Now, having a hitbox that's smaller by a couple floats does sound interesting, but it's actually not helpful at all by itself without a way to reset that hitbox back to its normal size. Fortunately, the way sneaking was coded between 1.12 and 1.13 is that it resets the player's hitbox to the original size when being used. I believe that was for the Y hitbox change in these versions, but a side effect of that is what allows us to complete the triple neo. The last second sneak in these clips is exactly for that purpose, resetting the hitbox, and I'll explain why. So as we know, collisions in 1.12 go in the order of Y, X, and then Z, giving us the famous X facing and Z facing we all know. The way this jump gives the apparent double Z landing is due to the hitbox change caused by the sneak. Sorry, but I'll have to get a bit more technical here. These are the tick-by-tick coordinates showing what happened in that last clip. All is normal until that last air tick. What we see is that we are rubbing against the wall on X, and our Z is past the blockage of the triple neo, being Z equals 8.3 in this case. Now as it is Z facing, normally the player wouldn't land, as following the collision order, we'd move in on X, hit the wall, then move forward on Z, and then on the next tick, the Y check would move us down and we would fail the jump. However, due to our smaller hitbox from before, when Sneak reverts it back to its original state, it appears that we have landed on X. Then remember, we already passed the blockage on Z, so when the game does its Y movement check on the next tick, there appears to be a block underneath the player, and thus we have landed the one block momentum triple neo. Now what does this mean for parkour on 1.12? Well, due to the niche use cases, that being jumps where the difficulty comes from a Z distance neo that has the same X landing as its last blockage, having to be around a power of 2 on X, and also having to set up chords with no access to sneak, and then actually having to perform the input itself, which I'd say is roughly a D5, it seems there will be minimal use for this quirk unless intended by the map creator in a difficult segmented map. Although, since most maps are built facing Z and around that X equals 0 area, where there are lots of smaller powers of 2, it is something that will need to be considered when making a high difficulty 1.12 map. Now, the only thing left to do is for someone to find a consistent way to manipulate the floats in our favour, but unfortunately, or fortunately in some ways, that might not be possible.